Hello my dear students, good afternoon. And now we will discuss about some numericals based on photoelectric effect. Actually photoelectric effect means we know that energy E is equals to W plus kinetic energy, right? So here if you read that numerical you can understand calculate wavelength of radiation. So asking wavelength of radiation what required. Okay, to eject electron to eject electron from potassium with kinetic energy given 2 calories and the threshold energy 3 calories. So what was given here very clearly? So kinetic energy was given as 2 calories, right? And threshold energy also given. Threshold energy means what? W. Threshold energy. So how much was given? It's 3 calories, right? So what asking? Lambda asking. Whose lambda? This energy. In this energy actually what is the formula? Hc by lambda, right? So there you have to calculate what is lambda. So first of all energy you have to find, because radiation has energy and with that energy you are sending that radiation through metal surface, and that particular radiation has energy means that particular radiation has some frequency, that particular have some wavelength like that. So, getting what I am saying? So it's very important. E is equals to hc by lambda. So you know this formula. Okay, so formulas if you know, first of all you can easily solve. And some people are asking how to calculate energy of 1 mole. You have a common sense. Energy I was given A is equals to N into H nu. This is Avogadro number into H nu I was given. So this all formula by okay 1 mole, okay, Avogadro number into H nu. This with clearly I was given like this. E is equals to 6.023 into 10 power 23 into H nu, like that. So for 1 mole means like this. Half mole also I told by 2 you have to do for this. So like that. So energy here not asking, right? So wavelength required asking. So you are sending particular radiation to eject electron, no? So that particular radiation has some wavelength which you are sending through this potassium. That wavelength you have to calculate actually. So E you don't know. So what is E? First of all, E is equal to, so very simple now. So it's 3 calories and this is 2 calories. So energy you have 5 calories. Get it? But here energy not asking. They are asking lambda. So to calculate lambda you must know energy. So energy you have. But in this formula what is H? 6.625 into 10 power minus 34 joules. Right? So that I am taking. And C value is in what? 3 into 10 power 8 meter per second, right? And lambda I don't know. Energy I know. Yes. But energy in calories I know here. So, but here H value in joules, SI unit. So, sir, it is in SI unit. So, this speed of light C should be in meter per second actually. If you have this, if you wanted to take this H value in ergs, then C value should be in centimeter. Be careful about all those things. So H value in joules, so both are in what units? SI units I was considered. So energy also actually 5 calories. So 5 calories can convert into joules. How? 1 calorie is equals to how much is it? E is equals to 5 into 4.2 joules now. Correct? Because 1 calorie is equals to, since you know 1 calorie is equals to 4.2 joules. Do you know this? So I was given already. So why I was converted into joules? Because H value in joules I was taken. Don't get confused. Always try to take in SI units so that you will. So if they are asking energy in ergs, then you have to take H value into 6.625 and 10 power minus 27 ergs you have to take. Understanding when you have to take ergs? If they are asking energy in ergs, in options given all energies in the form of ergs, then you can take H value in ergs. But otherwise, if you are asking some other thing like lambda or frequency, then you can take E value and that H value in joules. If joules, C value, speed of light in meter per second. This is very, very important to you. And now, if you see the, if you substitute all these things here, so what you will have energy, you know. So energy is how much? So therefore, it's a 5 to Z and 10 and 5 for 21 joules actually, 21.0, right? So energy, I have this energy. So energy is 21 joules now. This one is 6 point. So energy formula, you know now, that formula I will write otherwise first. Energy E is equals to Hc by lambda. So lambda asking, lambda is equals to Hc by E. So H value is 6.625. So for solving numerical, 6.6 is enough for H value. 6.6 into 10 power minus 34 and 3 into 10 power 8 and by energy how much is 21 joules now. This is in joules and joules. So lambda you will have in meters actually. If they are asking in ergs or like that, again you have to convert. Simplify this one and you can say answer now. Getting what I am saying? What I did understood? H value I was substituted, C value 3 into 10 power 8 and energy it's 21. So why it is 21 understood? So approximate I get 4.18 something. But for solving numericals, we need some speed, right? So 4.2 approximately you can take and multiply with 5. So around you will have 21. So lambda I am calculating by using this formula. So lambda is equals to Hc by E like this. So in this way you can solve numericals. Okay. So next, just have a look and write down all these things. Very, very important. Okay. Next, we will do same one more numerical based on this photoelectric effect. Yes. Calculate the wavelength of radiation. Instead, I will do one more thing. So here I am writing one more numerical. Okay. So calculate wavelength. Lambda means what? Wavelength to exact electron from metal surface. From what, sir? From metal surface. So calculate wavelength required. Wavelength actually required to exact electron from metal surface. So what required? Amount of energy required means what is the threshold energy? Amount of frequency required to exact the electron means what is the meaning? Threshold frequency. Same way, this is called threshold wavelength, it is asking. Understanding? Calculate wavelength required to exact electron from metal surface. If 4.2 calories energy sent through metal surface and assume velocity of ejected electron is 0. Understood the numerical, everyone? So how much energy they sent? Energy 4.2 calories energy of radiation they sent, and assume that velocity of ejected electron is 0. Velocity is 0. Velocity is 0. Velocity is 0 means what is the meaning? That V, velocity, V is 0. That means what is kinetic energy? Half mv square. Velocity is 0. Therefore, kinetic energy will be 0. Getting? So here what asking? actually what is the formula? E is equals to W plus K, right? So here kinetic energy will be 0 in this numerical. Why kinetic energy will be 0? Assume that velocity of ejected electron is 0. That means, what is the meaning? This will be 0. That means energy what we sent is equal to threshold energy. Understand? So what you can say therefore? So as K is 0, so you can take E is equals to W, that's it. So here H nu, this is H nu naught actually. Understanding everyone? H nu naught, W plus half mv square, no sir? Half mv square. Mass, velocity. Velocity of electron is 0. Speed of electron will become 0, means how much energy you send as in the form of radiation, total energy utilized to eject electron, means what the energy sent, total converted into threshold energy. 5 calories energy you send, suppose 5 calories energy is required to remove the attractive forces. Got it clearly? So H nu is equals to H nu naught. So H will cancel. So frequency of radiation what you sent and frequency what is required, both are same. Following everyone? Understanding? Frequency what you are sending and frequency what required to eject the electron, both are same. Suppose this is a metal surface, you are sending this much of frequency, and here this is a nucleus, and here to here you have attractions. To remove these attractions, some frequency is required, that is nu naught. Understanding? This nu, what is the radiation frequency? This nu naught, what is the frequency required to overcome the attractive forces between these two? Difference you are understanding, slowly understand, not a problem, but you have to understand. So between this nucleus and there is the outermost electron, and between them there is a attractive forces. Here what happened? Nu become nu naught, means total energy what you send, that utilized to overcome these attractive forces only. Therefore the ejected electron, so electron will fall down like this, so it will become energy 0, so velocity 0, kinetic energy 0. Kinetic energy 0 means, what is the meaning? Velocity 0. Understood? So here what happened? The frequency what you send and frequency what required to eject the electron, both became same. Then what you can say therefore? So this energy I have. So from energy, this nu I can find out. So what is nu then? Then E is equals to H nu. So first of all I have to find what is nu. Because calories, 4.2 calories energy sent, this side no. So 4.2 into 1 calorie. Actually 4.2 calories actually given. 4.2 into 4.2. This H value 6.6 into 10 power minus 34 into nu. So this nu you will substitute here. From that velocity, from that wavelength you have to calculate. This lambda you have to calculate. Or else here nu become nu naught. Now why you are doing like this? Simply Hc by lambda. This you can do now. Nu become nu naught, no sir. So E is equals to H nu. So this instead nu naught only you can take, because both are same. So lambda here only you can find directly. That's it. So very simple now. So what is lambda? So C value you can substitute. I'll write one more time. So here nu become nu naught. Therefore what I can say? Nu is equals to nu naught. Therefore you can write like this. E is equals to H nu. Got it? So what is the lambda asking? So H nu naught I can write therefore, because nu become nu naught. So E is equals to Hc by lambda. So again same story here. What is that? H 6.6 into 10 power minus 34 joules, and C value 3 into 10 power 8 meter per second, and lambda don't know, but energy given is 4.2 calories. So it's a 4.2 into 4.2 joules, because 1 calorie is 4.2 joules. So substitute lambda, you will have Because here nu and nu naught both are same. Why both are same? Velocity of ejected electron is 0. So for that, from that you can have lambda, because asking calculate lambda required. Wavelength required asking. From frequency, wavelength you can have. Frequency nu naught. Why here nu naught written in energy formula? Because nu is equals to nu naught. Got it? Simplify this value, and this value substitute and simplify. Then you can get energy, you can get wavelength. Can you simplify? Just do it now, very important. Okay. Now in photoelectric effect, we will have one more thing. What are those? 3 cases you have. So important 3 cases we will discuss in this photoelectric effect. So important cases, 3 cases. Case 1 in photoelectric effect. So in photoelectric effect, there are 3 cases we have to discuss. What are the 3 cases? If energy of radiation is greater than threshold energy. What is the threshold energy? Greater than threshold energy. If energy of radiation is greater than threshold energy, then what happens? Then photoelectric effect takes place. Photoelectric effect takes place. Correct? Yes. Because here amount of energy what you sent is more. So photoelectric effect takes place. Suppose I will give you one example. I wanted to buy a car with worth of 10 lakhs, but I have 15 lakhs. So what energy required? Threshold energy is how much? 10 lakhs. Because to have car 10 lakhs is required. But how much originally energy I have? I have a capacity of 15 lakhs. So 10 lakhs is the threshold energy and remaining 5 lakhs is the kinetic energy. Means remaining 5 lakhs I can spend for party. Getting what I'm saying? So total energy what I have is more than what required. I want 10 lakhs to buy a car, but I have 15 lakhs. So total my source, energy source, that is what? Understanding? Radiation is the energy source. So what is my source? My total sources is giving 15 lakhs. But to buy a car 10 lakhs is required. So remaining 5 lakhs is free. Understanding? So here I have a kinetic energy. I have some velocity because I have 5 lakhs. Understanding? I got a car with a 10 lakhs. I have only 10 lakhs. Then I don't have a single rupee to have a petrol even. Then can I run that car? Then my velocity will become 0. Getting what I am saying? The first case is I have more money. Like that, energy of radiation is greater than threshold energy. Then photoelectric effect takes place. Therefore, what you can say? E is equals to W plus K actually. So you can say H nu is equals to H nu naught plus kinetic energy actually. So sometimes difference in frequency also they will ask, sir. Then also don't get confused. Simply H nu minus H nu naught is equals to kinetic energy. Use more common sense, that's it. Very simple other way. See, H into nu minus nu naught is equals to kinetic energy. So here nu minus nu naught is the difference in frequency. That also they will ask you. So H is common, so nu minus nu naught here. So what is nu minus nu naught? Nu minus nu naught is difference in frequencies. Frequency of radiation, frequency required to overcome the attractive forces. Difference understanding everyone? So nu minus nu naught is difference in frequency. So case 1 over. What is the case 1? If energy of radiation is greater than threshold energy, then photoelectric effect takes place. Okay, next case 2. What is case 2? Same ulta, right? If energy of radiation, is less than threshold energy. What is T means here? Threshold energy. Then no photoelectric effect. No photoelectric effect. When there is no photoelectric effect, sir, if energy of radiation is less than threshold energy. As I told you, car example, I want to buy a car with 10 lakhs, but I have 6 lakhs only. Can I buy a car? Don't say smartly, sir, you can go for loan. Nowadays, nobody is giving loans. Understand? So, what I am trying to tell you here, I have less amount. Means amount of energy what required I don't have. Can photoelectric effect takes place? No. Can I buy car? No, I cannot buy that car. Understanding what I'm saying? Because car cost is 10 lakhs, but I have only 6 lakhs. So I cannot buy that car. Means energy source is less. Means that amount is less with me. Understanding? So here energy of radiation is less. So there is no photoelectric effect. Then there is no formula. So photoelectric effect not takes place. Not taking place. When photoelectric effect won't take place, understood? If the energy of radiation what required is less than threshold energy, then there is no photoelectric effect. Understanding, sir? Sir, 5 calories energy is required to eject electron to overcome the attractive forces, but you are sending 4 calories energy. Total energy required to overcome the attraction is 5, but you are sending 4 calories. Will electron eject? No way. So that is the second case. So you have 2 cases. So third case I will write here only. Can I write here? So here I will write case 3. What is that? Case 3. If total energy of radiation is equal to threshold energy. If total energy of radiation is equal to threshold energy. So as I told you in previous, I wanted to buy a car with 10 lakhs cost. I have 10 lakhs. Means my source of money is 10 lakhs. And what the car cost also 10 lakhs. So 10 lakhs I have, 10 lakhs is car cost. So neutral. Electron will eject, means just out of the particular what we call outermost shell. Okay, so here you have actually here like this is revolving. So here what calories? 5 calories energy is required. You send 5 lakhs. Sorry, 5 lakhs I am saying. 5 calories energy you sent. So 5 calories energy is required. So both will be same. Means 5 calories energy you sent, 5 calories energy is required to overcome the attractive forces. Both became same. Then electron will eject. So just electron will be in outermost only, just outside. It won't move anywhere. So this electron has kinetic energy 0 there because velocity become 0. Not frequency, sir. This is velocity. V become 0 because, so what I am saying, if total energy of radiation is equal to threshold energy, then what you can say, then photoelectric effect takes place, but then ejected electron has 0 kinetic energy because 0 velocity. Got it, sir, clearly? So these are about three cases. So here what we had means three cases we discussed. Like first case is what understood. When photoelectric effect takes place, understood. If we have more money than required, photoelectric effect takes place. Like amount of energy of radiation what you are sending is more than threshold energy, then photoelectric effect takes place. Even you can compare with threshold frequency also. You are sending 5000 hertz and required frequency is 3000 hertz. Then photoelectric effect takes place or not? Yes. Just listen what I am saying. Understanding? 5000 you sent. Got it what I am saying? 5000 hertz frequency you sent. This is frequency of radiation. Excuse me. Required frequency is 3000 hertz. Then photoelectric effect takes place or not? Yes, photoelectric effect takes place. When kinetic energy will become zero? When the amount of energy what you sent through metal surface is equal to threshold energy. What is threshold energy? Do you remember? The amount of energy required to overcome the attractive forces between nucleus and outermost shell. Because electron, which electron you can remove? Outermost electron only you can remove. Who is outer? That only will be removed, not in inner shells. Getting what I am saying? That's why I am talking between the attractions between the nucleus and outermost electron. Okay, sir? So these all things are very important. So today class is short somewhat, but I'll end this one because tomorrow freshly we will discuss about hydrogen spectrum, which is very important. Pakka in